Welcome all. The nucleus of this video is on re-engineering a coffee percolator to make it smarter. We are the tech newmen. My name is Lawson.
My name is Clinton Ahmed.
My name is Michael Tende.
And my name is Varun Ghosh.
Coffee percolators are a big part of our lives today, and they help us brew anywhere from 6 to 12 cups of coffee. We have successfully hacked a 40619 Hamilton Beach percolator and made it smarter. We have made it more user-friendly and by attaching an LCD system for better user interface. We have also embedded a microchip which has it automated, and the user can set its time, and at each interval the user has set, it starts brewing. This saves the user the stress of manually brewing the coffee. This also helps the user to go to sleep and wake up in the morning and see that the coffee is already ready. The team has also enhanced it further and given it different modes of coffee brew, like such as strong coffee and also the medium coffee, which the existing technology did not have before. A safety feature has also been programmed into it, and this makes it possible for the percolator not to come on except it has achieved a certain level of liquid range. This range was set to about 5 ml. All you've just heard from me now is the introductory part. I hand over to Clinton for the circuitry.
Thank you, Lawson. I will handle the DC component of our circuit. So I'm switching on our power supply. So our LCD takes 15 seconds to come on. So this one is our potentiometer. It helps to increase the brightness of our LCD. So we'll get back to this after the 15 seconds. We have this. This one is our alarm. What this does basically is, the moment our coffee has been brewed, it beeps. So let's go to our microcontroller. This is our PIC 1845K22 microcontroller. These are our electrolytic capacitors. They help for the bouncing of our push buttons. Then we have our potentiometer. This one helps to vary the water level of our percolator. Then we have this push button is for reset. This one is for, it helps to reset the entire circuit. This one helps to when you want to put the time set for the brewing process. This third button is called the multi-purpose button. It helps to set the time for each coffee, the strong, the medium, and this one helps for increment. This one is for decrement. This one is for our relay. This one is the power out, whereas this one is the one power in. So as you can see now, our LCD is on. So now we can vary the potentiometer to increase the brightness, as you can see. So that's our DC component of our circuit. Thank you. I'd love to introduce Michael and Varun to handle the working operations of our circuit.
So now we will show you the working operation of the enhanced coffee percolator. First, we have placed 6 milliliters of water in the jug, as you can see there. Now we will place our coffee into the coffee basket. We close it up. Lights. Okay. Then we have adjusted with our potentiometer. We have adjusted the level to also 6 milliliters, just as it is on our percolator jug. So now,
As you can see, I'm setting the desired time right now.
right now, the time is set to 1:25 a.m. and the current real time is 1:24 a.m. So in a minute's time, the percolator will come on automatically.
And we can see that this blue light will go on. We have connected the power supply to the main AC. And as we wait, we'll able to hear a click sound. That means the relay is turned on. As you can see, the light is turned on right now, and see the message on light coffee brewing. Now this operation will go on since the water level is at 6. The brewing operation will go on for approximately 6 minutes. Now let us talk about the AC circuit for the time. And now I'll be talking about the different operations of our percolator. We have 4 different components: main relay, heat sensor switch 2, relay control, and a power supply. The main relay is turned on when the desired time is equal to the desired time is equal to the real time and the water level is above 5. Heat sensor switch is generally in the on state and it goes off when the temperature rises above the desired temperature. In this condition, we are switching off the relay, and since the heat sensor switch is on, we have no response from the power supply. In this condition, we are brewing light coffee. In the second condition, the main relay is still on, but our heat sensor switch goes off, due to which we now have a response across the power supply. In this condition, we are warming the light coffee which is already prepared. In the third condition, we brew strong or medium coffee as selected by the user. The main relay is still on, and since our heat sensor switch is off, we turn the relay control on, due to which the response is now 0 across the power supply. In this condition, we are brewing medium or strong coffee. For the final conditions, heat sensor switch is off and the previously turned on relay control switch is now off, due to which we have a response across the power supply. In this condition, we are warming the previously prepared medium or strong coffee. Thank you. As you can see, the green light is on, and that means the warming operation has been done. As you can see, the buzzer is on, and we have a message: light coffee ready. Now I've selected different coffee, a strong coffee, and as you can see, it is turned back on. Now it will go for at least 1 minute before going back to the warm condition. As you can see, the green light is back on, the buzzer is on, and we have a message on the LCD which reads strong coffee is ready. Now I'll pour the strong coffee for my
Thank you. Damn, it's hot. Tastes good though. Very good, but it's very hot still.
Thank you so much. And now I would like to welcome Michael Walker to talk about problems encountered.
Thank you, Varun. Now I'll be talking about the problems encountered while working on this project. One of the problems encountered was working on the LCD. It was very hectic and it required a lot of tests and continuous programming. At first, we found it hard to initialize the LCD, but eventually we were successful with this, and that was when we encountered the next problem, which was displaying our information to the LCD. Successfully, we got everything working and we delivered on the deliverable. The LCD now shows the real time, the desired time, and also shows when the percolator is brewing and when it's done, which makes it user-friendly for the user also. The second hurdle that we encountered was working with the pressure sensor, which is for the safety feature that we added to our design. The pressure sensor works with a range of 20 grams to 20 kilograms, but our safety level works in a range of 0 to 5 kilograms. Because of this large difference in range, we were unable to calibrate our readings we were unable to calibrate the pressure sensor into giving us accurate readings whenever we took measurements of the percolator jug. We tried using a smaller pressure sensor, but we still did not get accurate readings. So to solve this problem for ourselves, we decided to use a potentiometer and calibrated it into different varying levels according to the water levels on the percolator jug. Now, the second hurdle that we encountered while working on this project is with our pressure sensor, which is for our safety feature. We use a thin film pressure sensor that is highly sensitive with a range of 20 grams to 20 kilograms. But for our water level safety, we are working with 0 to 5 kilograms. Because of the indifference in this ranges, we found it hard to calibrate the pressure sensor into giving us accurate readings whenever we used it to measure our percolator. Now, here we have our pressure sensor. We place the pressure sensor in between two foams like this, so that whenever we place our percolator on it, it causes a strain on the pressure sensor, thereby giving us a reading of the mass of the jug. But due to the surface area of the jug, of the percolator base being very high, being very large, we could not get accurate readings with this pressure sensor. So at the end of the day, we were not able to calibrate the pressure sensor accurately. So we decided to solve this problem using a potentiometer. The potentiometer was calibrated into 12 different levels, which signify the 12 water levels of the percolator jug, with the highest being 12 milliliters and the lowest being 0 milliliters. Now, we placed our minimum level for safety at 5 milliliters. So if the water level is below 5 milliliters, the percolator will not come on. It will only come on above 5 milliliters. Now I would love to hand over to Clinton to take over the recommendations for the project.
Thank you, Michael. And I will handle the recommendations for our project. So we are recommending as a team that we replace this heat sensor switch with a temperature switch in series with our relay control. And for the safety, we recommend that a sensor will replace the pressure sensor that is used, that will record accurate readings of the water level, and so that it won't lead to overheating of our circuit. I would love to hand over to my colleague Lawson to handle the conclusion.
In conclusion to all the team has said and all you've heard, we have come to the conclusion of this presentation. The team is certain that at this point, any percolator can be remodeled and be made into a smart percolator. The team will now take your questions. Thank you.